everyone, this is Miss Yanson, and I'm making this video to give us, to go through the PowerPoint that we have for section 10.3 on further identities. When I teach this class in person at other colleges, I find that this lesson could be one of the more challenging ones to understand, and so I didn't want to leave you all with only a PowerPoint to look at. So please, as you are going through this video, if there's something, a step that I make or something I'm explaining that's not making sense to you, pause the video, make a note of what time in the video it is, and shoot me an email and say, hey, at 15 minutes and 47 seconds, you said, I don't understand what's happening in this step. I don't understand how you're getting from there to there. Shoot me an email. I'm happy to get on Zoom with you, or we can chat back and forth via email to make sure that you understand this. Because remember, a part of your test score will come from me manually grading the work that you're writing down on your paper, right? So I want to make sure that if you have any questions that we get them addressed. Let's get started. Hello everyone. In this video, we are going to discuss section 10.3 on further identities, and we're going to begin by talking about double number identities. So we have several different identities here that we will use to evaluate sine, cosine, and tangent at double angles. So what I mean by that is that all of these trig functions have 2 times the angle as the input. You'll notice that there are 3 different formulas, all for cosine 2a. Later on in this course, as we work on solving trigonometric equations, we will use those 3 formulas discriminately. But for now, as for just evaluating these function values, we can use them indiscriminately. So let's jump in and look at our first example. So in this example, we are given that cosine theta is equal to 3/5 and that sine is less than 0. And we are asked to find 3 different things. We are asked to find sine 2 theta, cosine 2 theta, and tangent 2 theta. So we're going to be using these formulas from earlier to evaluate these 3 things. So I'm just going to copy over these formulas and then we'll work on filling them out. So for sine 2 theta, I'm going to be using this sine 2a formula. So just swapping out a with theta, this will be equal to 2 sine theta cosine theta. I just filled out this right here. For the cosine 2 theta, we have 3 choices. We can either use this one, or this one. I'm going to choose to use this last third one right here. And when we get to evaluating this, I'll explain why I chose this one. So I'm just replacing a with theta. I have that formula filled out there. And then for tan 2 theta, there's 2 options here. We can either use this formula of 2 tan theta divided by 1 minus tangent squared theta, or we could use the fact that we know by definition that tangent is equal to sine over cosine. Now because there's a 2 theta on the inside here, I want to make sure that I'm putting a 2 theta on the inside of both of these. So if we're able to find the first one and the second one, then we can just plug them in and be left with what tangent of 2 theta is. So now let's take a closer look at how we're actually going to evaluate these. So in the problem, we were given that cosine theta is equal to 3/5. So for some of these, we can go ahead and start filling some things in. For instance, I'm going to move some things around here so you'll see how things are actually going to be plugged in here. So I'm going to just separate these 3 formulas and then we'll attack them individually. So for the sine 2 theta one, well, I don't know what sine theta is. That wasn't given to us, but cosine theta was given to us. It was given to us as 3/5. So we have part of that formula filled out. Now let's move on to the cosine 2 theta formula. I chose the version 2 cosine squared theta minus 1. So remember, we had 3 choices we could have picked, and I chose the one that's highlighted in yellow. And the reason that I chose that one is because this formula only involves cosine, and cosine was given to us in the problem. So that just makes it a little bit easier. I can just go ahead and plug in for cosine. It does need to be squared. So I'm going to plug in the 3/5 that we were given for the value of cosine and square it, and then I will subtract 1. And I don't know what tangent is over here. And we also don't have these two answers either, and so I'll just leave that tangent 1 blank for now. I can go ahead and finish computing the cosine 2 theta problem. This is 2 times 9 over 25 minus 1. Do make sure to square that numerator and that denominator. And then just evaluating this, we are left with a negative 7 over 25. And that is our answer for cosine 2 theta. Now let's go on to finish finding sine 2 theta. So the problem here is that we don't know what sine theta is. We need sine theta. We do know what cosine theta is, but we have lots of different ways to find sine theta. I could use a right triangle. I could use fundamental identities. I'm going to choose to use a right triangle. So I'm going to set up a right triangle. I'm going to place my angle theta. In right triangle trig, cosine is adjacent over hypotenuse. So I'll make the adjacent side 3 and the hypotenuse 5. Using Pythagorean's theorem, we could quickly see that this opposite side must be 4. 3, 4, 5 is a very common Pythagorean triple. The definition of sine theta in terms of right triangle trigonometry is opposite over hypotenuse. The opposite side is 4 and the hypotenuse is 5. Now at this point we have to be careful because the problem told us that sine theta is less than 0. That means that sine theta is negative. So I do need to make sure that I am applying a minus in front of that 4/5. So now that we know sine theta is a negative 4/5, we can plug that into that formula there, and now I'm just left to finish my calculation. We have 2 times negative 4/5 times 3/5. Multiplying all of that gives us a negative 24 over 25. And now we have our answer for sine 2 theta. Now that we have both sine 2 theta and cosine 2 theta, we can come in and finish evaluating tangent 2 theta, because tangent 2 theta is sine 2 theta, which is a negative 24 over 25, divided by cosine 2 theta, which is a negative 7 over 25. And now I will just simply do that division. We divide fractions by multiplying by the reciprocal. The 25s cancel, the two negatives cancel each other out, and we are left with a positive 24 over 27 for our answer for tan 2 theta. Okay, so notice that for all 3 of these, I started by making sure I was using a double number identity. One of the most common mistakes I'll see is people will see this problem and they'll say, oh, we have cosine. We're being asked to find cosine 2 theta, and they will just multiply what I gave them as cosine by 2, which is incorrect. The answer should not be 6/5. For one, cosine can never be greater than 1, so that should be a huge red flag right there. If you're asked to find cosine 2 theta, you need to go in and use a double angle formula for cosine. Either this one, or this one. Same thing for sine and same thing for tangent. In this problem, we're going to be doing almost the same thing, but working backwards in the opposite direction. They have given us that cosine 2 theta is equal to 4/5. And we're being asked to find the values of the 6 trigonometric functions of just theta. So the one they gave us had a 2 theta on the inside. They want us to just find cosine theta, sine theta, tan theta, and the reciprocals of those functions, which are secant, cosecant, and cotangent. Notice that the 6 trigonometric functions that I wrote only have a theta on the inside. There is no 2 theta on the inside. So what I'm going to do is I have the value for cosine 2 theta. I'm going to scroll up to my double angle formulas. There's 3 choices that we have for cosine 2 theta. Remember, we're trying to find cosine and we're trying to find sine. So I would not want to use the first version because the first version has both cosine and sine in it, and so I wouldn't actually be able to solve for anything. I could choose to either use the version that has cosine or the version that has sine. Let's choose the version that has sine. And then later I will come back and use this version here that has cosine, and you'll see how we use that in just 1 second. So the version that has sine in it tells us that cosine 2 theta is equal to 1 minus 2 sine squared theta. So I'm going to plug in what they gave us for cosine 2 theta. It was 4/5. And then we are going to solve for sine theta. So I'm going to subtract 1 from both sides of this equation. 4/5 minus 1 leaves us with a negative 1/5. I'm then going to divide both sides of this equation by the negative 2 so we can get the sine squared by itself. That's going to leave us with a positive 1/10 is equal to sine squared theta. And then to actually get sine by itself, we're going to have to square root both sides. And this is where we need to be careful because they did give us this inequality that tells us that the angle theta is between 90 degrees and 180 degrees, meaning that that angle lands in quadrant 2, where the x-coordinate is negative and the y-coordinate is positive. So because the y-coordinate is positive, we will be choosing the positive square root because we are in quad 2. So we are left with sine theta is equal to the square root of 1/10. I'll break that up into the square root of 1 over the square root of 10. The square root of 1 is just 1. And then finally, I will rationalize this by multiplying by root 10 over 10 to get that sine theta is equal to root 10 over 10. I think I misspoke here. I rationalized it by multiplying it by root 10 over root 10. So we have a part of our answer. We have our answer for sine theta. We still have a lot of other things to find, but once we have sine theta, we very quickly get cosecant theta because all I have to do is take the reciprocal of sine in order to get cosecant. And just to make things a little bit easier for us, I'm going to choose to take the reciprocal of this version of it. All right, so we had at one point that sine theta was equal to 1 over root 10. When I flip that, I see that cosecant theta is equal to root 10 over 1, and I don't have to write the denominator for 1. Okay, so we have found sine theta. Now let's go on to find cosine theta. There's lots of different ways you could do that. One thing you could do is you could use sine squared theta plus cosine squared theta is equal to 1. Very popular Pythagorean identity. We could use that to solve for cosine theta. Alternatively, we could remember that we do have cosine 2 theta given to us, and instead of using a version of that double angle identity that only involves sine, so remember I started off and I chose to use this one, I could now do the same thing and use this version that involves cosine. So that way we could then solve for cosine. So that version tells us that cosine 2 theta is equal to 2 cosine squared theta minus 1. So I'm again going to plug in what we were given for cosine 2 theta, which is 4/5. And then I'm going to follow a very similar process and I'm going to solve for cosine theta. So I'm going to start off by adding 1 to both sides of this equation. 4/5 plus 1 will give us 9/5. We'll then need to divide both sides of this equation by 2 in order to get the cosine squared by itself. And then once we have cosine squared by itself, we'll need to take the square root of both sides to get rid of the squared. And when we do that, again, we need to be careful because we were told that the angle theta was in quadrant 2, where the x-coordinate is negative. And remember that cosine is the x-coordinate, so we are taking the negative square root here. So we have that cosine theta is equal to negative root 9 over root 10. The square root of 9 is 3, and I will then rationalize this to have negative 3 root 10 over 10. So now we have a value for cosine theta. I'm going to quickly flip that value to get an answer for secant. I'm not going to flip this one because then that would give me a root in the denominator and I'd have to rationalize it. I'm just going to choose to flip this one so that we don't have to rationalize to see that secant theta is equal to negative root 10 over 3. The last two trig functions we're left to find are tangent and cotangent. But once we have sine and cosine, it's pretty straightforward on how to find tangent because we know that tangent is equal to sine over cosine. So this is going to be equal to sine, which was root 10 over 10, divided by cosine, which is negative 3 root 10 over 10. We divide fractions by multiplying by the reciprocal. So we're taking the numerator and multiplying it by the reciprocal of the denominator. The 10s will cancel and the root 10s will cancel, and we'll just be left with tangent theta is equal to a negative 1/3. And if tan theta is equal to a negative 1/3, then the reciprocal of that cotangent theta is equal to a negative 3. And that gives us the values of all 6 of our trigonometric functions. In our next example, we're being asked to write sine 3x in terms of sine x. That means we want to rewrite this where the only trig function that we're seeing is sine x. We just want to have x on the inside. We no longer want to have 3x on the inside. So the first thing I'm going to do is observe that I can break up 3x by writing it as 2x plus x. And the reason that I'll do that is because it goes back to a formula that we used previously in this course for a sum of sine, or rather sine of a sum. So I've pulled this screen clipping over from our chapter 10 identities sheet. And I'm going to be using this sine a plus b formula because as you can see, we kind of have this broken down where a is the 2x and b is just the x. So now I'm just going to plug into this formula. So I now have sine 2x multiplied by cosine x. And then to that, we are adding cosine of a, so that's cosine of 2x, multiplied by sine of b, so that's being multiplied by sine of x. And from there, we're going to continue to simplify this. Now remember, we don't want anything in this function but sine x. So far, only this factor right here is good. There's other things that are showing up in here that are not sine x. One of them is this sine 2x. So to address that sine 2x, I'm going to scroll up to the top where we have our double number identities. Think about replacing a with x. I'm going to be using this formula here. So I'm going to replace sine 2x with 2 sine x cosine x. There was already a cosine x that was multiplied by, and then we're going to add, and we're going to do something similar with this cosine 2x right here. I'm going to again scroll up to the top. I have 3 options for which I could replace cosine 2x with. I'm going to choose to replace it with this version because remember, we only want to see sine x in our new identity. We don't want to see cosine in it. We don't want to see cosine in it. So I'm going to choose to use this version of 1 minus 2 sine squared x. So I'm replacing this cosine x with 1 minus 2 sine squared x. And I'm going to leave the sine x here that it was multiplied by. So first, let's just take some time to simplify what we have here. We have 2 sine x. Cosine times cosine will give us a cosine squared x plus, please do make sure when you replace this cosine 2x that you have it wrapped in parentheses. So you observe that we do need to distribute here. 1 times sine x is sine x, and 2 sine squared x times sine x will give us a minus 2 sine cubed x. Okay, so let's move forward. So far, we're getting a lot closer. Remember, we only want to see sine x. I am seeing some sine x's. It's okay that this is cubed. That's still a sine x. It's just 3 of them multiplied together. But what's still not okay is this cosine squared x. But I hope that you feel good about that because we do know how to rewrite cosine squared where we only see sine. We know the very popular Pythagorean identity that says cosine squared plus sine squared is equal to 1. So I can use that identity to realize that cosine squared x is equal to 1 minus sine squared x. So let's now go in and replace that cosine squared x with 1 minus sine squared x. And then I will bring down my plus sine x and my minus 2 sine cubed x. Let's go back in and simplify. We need to be distributing here. So this is a 2 sine x minus 2 sine cubed x. The one on the outside is just to the first power. Multiplying that by something squared will give us something cubed. And then I'll bring down everything else that we already had there. And now we're going to do some simplifying. We have some like terms here because we have a 2 sine x and just a sine x. Those two will come together to give us a 3 sine x. And then we have a negative 2 sine cubed and another negative 2 sine cubed, which will come together to give us a negative 4 sine cubed x. And now notice that everything now in this last line is written in terms of sine x. Now, one thing I will say about this problem, as you see similar problems in your homework, is please do not think that there's always going to be some straightforward set of procedures that you will follow. It very much so depends on what you're trying to write your function in terms as. So what I mean by that, for example, when I chose to replace cosine 2x with this of my three options, I intentionally chose the version that had a sine in it because I only wanted to see things that had sine in it. So some of the choices that you make will be guided by what you're trying to get to. Now we're going to move on. We've been talking about double number identities. Now we have a set of half number identities. They're posted here. Notice that we now have three different versions for what we could do for a tangent half angle formula. Just as we've seen before, which version we use will depend on which version is convenient for us. Let's jump in and look at an example here. We are asked to find the exact value of cosine pi over 12. Now, if this pi over 12 were pi over 6 or pi over 3 or pi over 4, we could do this problem very quickly by just looking at the unit circle. But pi over 12 does not show up explicitly on the unit circle. Moreover, this says find the exact value, which means that it would be insufficient for us to just grab our calculator, put it in radian mode, and see, oh, cosine pi over 12 is 0.9659258. That would be marked wrong. That's an approximation. That is not the exact value. So to find the exact value, we're going to be using a half number identity. And the reason that we're going to use a half number identity is because we can recognize that cosine pi over 12 is cosine of pi over 6 divided by 2. If I take half of pi over 6, then I have pi over 12. Now, how does that help us? Well, now this looks very similar to this, where A, what's being divided by 2, is just pi over 6. Okay? So now I'm going to fill in this formula. Now this formula says this is equal to plus or minus the square root of 1 plus cosine A. In our case, A is pi over 6, and then this is divided by 2. Before we go any further, let's deal with this plus or minus and talk about which one we actually choose. Well, pi over 12 is in the first quadrant. It's half of pi over 6, so it's a pretty small angle. In the first quadrant, the coordinates go plus, plus. So because x is positive in the first quadrant, we will be choosing the plus. So I'm going to erase that plus or minus and only leave a plus right there. Let's go on and continue evaluating this. You'll notice that we do have that pi over 6 left in our expression, and that's a good thing for us because we know the exact value of pi over 6. Cosine of pi over 6 is root 3 over 2. All of this is still over 2. We're going to simplify this. We have this fraction within a fraction, so to get rid of that, we're going to come in and multiply everything, all three terms of this, by 2, leaving us with the square root of 2 plus. The whole reason that we multiplied everything by 2 was so that those 2's would cancel, so we have a 2 plus root 3, and then all of this is divided by 4. And the last thing we'll do to simplify is we will take the square root of the numerator and the denominator individually because the square root of 4 is just 2. And there is our answer. Now, when you go and you work your homework, you will see variations of these problems. So for example, you might see something like find sine of 75 degrees. Okay. Then you have to realize, well, 75 degrees is half of 150 degrees. So I can rewrite that as sine of 150 over 2. And the reason you would do that is because now this looks very similar to this, where now A is equal to 150 degrees. And then you would go in and fill out that formula. You would again have to think about whether you want to choose plus or minus. One word of caution, when you're choosing plus or minus, it depends on what quadrant this angle is in. 75 degrees is an acute angle. It lands in quadrant 1, where both the x and the y coordinates are positive. So when you actually go to fill out your formula, you would make sure to choose plus. What you would not do is you would not look at 150 degrees and say, oh, 150 degrees is over here, which is still a positive y coordinate, so you would still be choosing plus, but that's not always the case. So moral of the story is whether you're choosing plus or minus depends on what quadrant the angle you are evaluating the trig function at lands in. Moving on to our next example, we're given that cosine x is equal to 2/3. They give us an inequality that tells us about the quadrant that x is in, and we're asked to find cosine of x over 2, sine of x over 2, and tangent of x over 2. Hopefully this feels familiar, like how we did earlier with these double angle formulas. Up here where we were asked to, well, no, not this example. Rewind, right here. We were asked to find sine 2 theta, cosine 2 theta, tan 2 theta. So if you recall, the first thing I did was I went and I wrote down the formulas. So I'm going to do this very same thing here. I'm going to be filling out these with some half angle formulas. So for cosine x over 2, I'm using this formula here. It's going to be plus or minus the square root of 1 plus cosine x over 2. For sine x over 2, the formula is plus or minus the square root of 1 minus cosine x over 2. And yes, there are 3 different versions that you could choose for tangent x over 2, but just like we did last time with the double angle one, I'm going to use the fact that tangent is sine over cosine. So once I get my answer for sine x over 2, I'll just divide that by my answer for cosine x over 2. So now let's go in and actually evaluate some of these things. For now, I'm just going to leave the plus or minus there. This is going to be one of the easier problems because they explicitly gave us what cosine x was. They told us that cosine x is 2/3. That's what we're going to plug in there, and that's what we're going to plug in there. So let me go ahead and do that. Now, before I go on and finish evaluating these, I want to have a brief discussion about what if they didn't give us that, and what if they told us something like sine x is equal to 4/5. So if we were given something like this, we would still have to figure out, well, what is cosine? But we know exactly how to do that. We could use a fundamental identity, like sine squared plus cosine squared is equal to 1, or we could set up a right triangle and use the right triangle to solve for cosine. So sometimes you might not have what you need, but the good news is we've already learned how to find what we need if it was not given to us. If you come across any problems or you need some help, of course, never hesitate to reach out. Okay, let's talk about these pluses or minuses because it'll be pretty straightforward for us to evaluate the numbers under the square root. But whether we're going to choose plus or minus depends on what quadrant x over 2 is in. Remember, that's where we're evaluating sine and cosine at. Now, they did give us this inequality here that gives us information about what quadrant x is in. We know that 3 pi over 2 is less than x is less than 2 pi, which then tells me that x is in quad 4. I know where 3 pi over 2 is, and I know where 2 pi is. But again, we need to know about x over 2. So to give me some information about x over 2, I'm going to divide everything by 2. So now we have x over 2 in the middle of our inequality. 3 pi over 2 divided by 2 is 3 pi over 4, and 2 pi divided by 2 is pi. Well, 3 pi over 4 is over here, and pi is over here. So the angle x over 2 is somewhere in quadrant 2, where x is negative and y is positive. Well, if x is negative, that means that cosine x over 2 would need to be the negative square root. And if y is positive, that means that sine x over 2 would need to be the positive square root. So when you're determining whether you're going to choose plus or minus, you need to take what you know about x, the whole angle, divide that inequality by 2 to get some bounds for x over 2. And then think about what quadrant that is in, and then choose your signs accordingly. Okay, so let's finish evaluating what's under the square root. I'm actually just typing all of this into my calculator. 1 plus 2/3 divided by 2 gives me 5/6. And then 1 minus 2/3 divided by 2 gives me 1/6. I'm going to break this up. I'm not going to leave them with these square roots inside of here. I'm going to rewrite this as the negative square root of 5 over 6. And then I will rationalize this to give me negative root 30 over 6. And that's my answer for cosine x over 2. I'm going to do a similar thing with the answer for sine. I'm going to break this up into root 1 over root 6. Well, root 1 is just 1, so this is 1 over root 6, which will rationalize to be root 6 over 6. And that's my answer for sine x over 2. And now that we have both cosine x over 2 and sine x over 2, we can come over here and plug in to find tangent of x over 2. In the numerator, sine was root 6 over 6. In the denominator, cosine was negative root 30 over 6. I'm going to take my y value, divide it by my x value by multiplying by the reciprocal. My 6's will cancel. I'm left with a root 6 over a root 30. One way for me to simplify this is to you could come in and rationalize it, yeah, and multiply by root 30 over root 30. Your numbers might get kind of large. So I'm just going to rewrite that root 30 as a root 6, root 5. So I can see that I can cancel my root 6 and be left with a 1 over root 5. And I dropped a negative. Let me not drop my negative. Put that back in, this negative right there. And then I'll rationalize that to be left with a negative root 5 over 5. And that is my answer for tangent of x over 2. Next, we're going to look at using some new identities. They are called product to sum identities because they tell us how to take a product of either cosine times cosine, sine times sine, sine times cosine, or the reverse of that, and turn it into a sum, or a difference for that matter. So here in this example, we have cosine 2 theta multiplied by sine theta, and we want to write that as either a sum or difference of the two functions. One thing I will point out is if you're starting with a product and the directions ask you to write it as either a sum or difference, that should be an indication to you that you should be using a product to sum identity. Now we have one that goes cosine function, sine function. So I'm going to choose the version of the formula that has a cosine function and then a sine function. So in this case, our A is the 2 theta, because that's what's inside of cosine, and our B is just a theta. So we're going to work on filling out the right-hand side of that formula. So this is equal to 1/2, open up a bracket, sine of A plus B, so that'll be 2 theta plus theta, close parentheses on that, and then subtract sine of A minus B. So that's a 2 theta minus theta. And now we'll work on simplifying this. So we have 1/2 sine 2 theta plus theta is 3 theta. And then inside of our next sign, we have 2 theta minus theta, which is just theta. Last thing I'll do is I will distribute the 1/2. So we have 1/2 sine 3 theta minus 1/2 sine theta. Next round of identities that we have are sum to product identities, which tell us how to take a sum of either a sine plus sine, a sine minus sine, cosine plus cosine, or a cosine minus cosine, and to write it as a product of trig functions. So in this example, we are starting off with a sine 2t minus sine 4t, and we want to write it as a product of two functions. So I'm going to choose the version of these formulas that goes sine function minus sine function. So we'll be using this identity. Thought that was a highlighter. We'll be using this identity right here. In our case, our a is equal to 2t, because that's what's in front of the first sign, the positive sign, and our b is equal to 4t, because that's what's inside of the negative sign. So let's start filling out this identity. So filling out the right side, we have 2 cosine, open up my fraction there, a plus b in the numerator, so that's 2t plus 4t. In the denominator, we simply have a 2, and then this is multiplied by sine of a minus b, so that's a 2t minus a 4t, and all of that is divided by 2. Let's go on and continue simplifying this. So we have 2 cosine of 6t divided by 2, and that's multiplied by sine of 2t minus 4t is a negative 2t divided by 2. I'll keep simplifying here because 6t over 2 is a 3t, and negative 2t over 2 is a negative t. But we did learn that sine was an odd function, which means that this negative can be brought out. I'm going to bring it out all the way in front of that 2, leaving us with the negative 2 cosine 3t sine t. So one reason that I made this video is because when I teach this class in person, I think that this could be one of the harder lessons in the course, and I didn't want to leave you all with just a PowerPoint to look at to understand this. So please, 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 if you have any questions as you have gone through this video, please do not hesitate to reach out to me. I am here and I am happy to help you.